Trade actors generally use multiple CTU features as well as different infrastructures for different purposes. Some of those must be hidden, some of those must be evasive. On the other hand, some of those must be interactive, even if it is noisy. They ignore it and they do their actions anyway. There are some reasons for it. The first one is they need to be evasive because they may plan a long-term deployment. For example, 3 months or 6 months to get the correct resources to reach the Swift transfer that could utilize, let's say, $100 million to another country. So it is not a kind of simple operation. This may take months. On the other hand, when they identify their exact target, for example, the user that can start the Swift transfer, they need interactive actions. Interactive actions can be performed using some interactive tools. Metasploit framework or COBOL Strike, they show up in that stage. Generally, they are too noisy, especially Metasploit framework is quite noisier. They are quite useful for some interactive actions, even though they are noisy. COBOL Strike provides some additional customizations features, and it is less noisy. On the other hand, it doesn't have any exploits. It doesn't have any other Metasploit helpers or auxiliary tools. That's why even most common trade actors, they use Metasploit for some interactive actions, such as RDP or eternal blue exploitation or some other privilege escalation exploits. In these days, they try to migrate almost all of these stuff, their exploits and tools and etc., to the .NET or COBOL Strike C codes, the objects. So they are portable and they can run through the actually CTU environment, and they can be more evasive. Let's talk about Metasploit and how we can deploy the Metasploit under this virus protection. Let's check our settings back again. Real-time protection is on, cloud delivery on, and automatic sample submission is on. So everything is set up. Now we run the Metasploit. Metasploit can run using MSF console on Kali, and it will load thousands of different modules to be used through the Metasploit framework. And what we are interested in here is actually generating the payload and then using a handler. They are our main concerns, because Petaq service is able to inject process. So they can inject some certain shellcode. It's also called process injection or DLL injection or shellcode injection. There are several different techniques here, but Petaq is using create process suspended, and then it actually adds a different feature here. It spoofs the parent process and then adds the shellcode as a new thread, and it uses QUser APC to resume the thread. So what we can do here is introducing a shellcode. Our previous example was calc. Let's see how Metasploit can be used to generate payload and how we can make it running. Payload can be used like this. If we use the payload name, it will be used, and show options will show the features of it. And if we set the CMD for an exec payload, because this payload simply executes a process given command, and this is for x64 architecture, and we can generate this as well. Generation has different options. If you use generate H, you will see that different output formats is available, as well as there are different encodings and other features. We don't need any of those. We only need one thing here, which is to generate a raw component, raw shellcode. And the shellcode will be saved as this file. So we will introduce this file to our Petaq. Now I'm generating this file, and it is saved as this file, the calc, and it is raw shellcode that runs the calc. Let's run this feature again. First, we need to use our implant, and we will give the same command back again. Exec shellcode, the file, and x64. It will use process injection, and as you see, the calc has started. Now, let's make things complicated, and just like a threat actor. The threat actor is not interested in calc, right? This was only a demo. So let's go back and use Meterpreter, reverse HTTPS payload for the x64 architecture. In this case, reverse HTTPS can be used, and it is a simple stager. It will load the second stage through the Metasploit. So what we need to do is actually setting a couple of things for it. They are our localhost IP address, which is this, and a port. This port will be used by Metasploit. Don't get confused with Petaq service ports such as 80 or 443. They are used for the Petaq service and Petaq Implant communications. But this time, Meterpreter will need another communication channel, just like this. So this one must be another port. That's why we use port 8080. And now let's generate this and let it run. This is the file we generated. So we will give exactly this command to run. However, when this command runs, it runs a stager. That means a dropper. It will simply look for a service that it can connect back and to be handled by Metasploit. In this case, Metasploit multi-handler would help us to serve that implant the second stage, Meterpreter second stage. Exploit multi-handler is not an exploit. It is a simple handler. It is handling the oncoming requests for different payloads. So you need to set the payloads like that. We use Windows x64 Meterpreter reverse HTTPS payload, and our settings were actually IP address and port. When we run this exploit, we don't need it to exit whenever it receives a shell. Maybe we will use multiple shells. So I prefer to run this with no exit on session. And this exploit job is created. And in jobs section, we can see it. It runs. Now we need Metasploit payload, Meterpreter payload to run through Petaq service that also executes this on Petaq Implant. So let's give this same command, just like this, but this time the file changed. The file is now Meterpreter. Any detection? No. Any shell? Yes, we have a shell. This is the sessions. And there's a new session here. And this is the session info. So this is what we see. The dev can run Meterpreter in memory because we didn't use any file. We use Meterpreter as raw shellcode, just going back to capture this image again. We use raw shellcode of Meterpreter. We give our IP address, and we actually ask Petaq service and implant to run this. Petaq Implant introduced the stage one connected back to Metasploit on this port and this IP address to get the second stage, and then communication established, and we have a Meterpreter session here. So now we are good here, and everything must be okay, right? That's not exactly true. As we previously have seen, our privileges are quite limited. Our next video will solve this challenge.